Okay, so there's a lot of concepts that go with the confidence interval. Yeah. So we can kind of go through this problem. Assume that nothing is known about the percentage of adults who gamble online. Let's take a look. So to do this, we don't have to, kind of do the algebra, but I want to kind of quick show you the derivation. It's just kind of whether or not you like algebra. But whenever they ask you for sample size n, we have margin of error, of course, is z from the previous video. P hat q hat over n, the square root. So we literally just, all we're doing here is we're solving this thing for n. We call it algebraically solving it for n. But if we have this equation, yeah, there's people quite oftentimes they get confused and angry about the algebra because the bottom line is there's always going to be more than one way to write the algebra. Yeah. But we do have E over Z equals that. This is just kind of the quick derivation that we can definitely skip. Yeah, to get rid of a square root, we have to square both sides, yeah. And then what do we have? We have P hat Q hat over N equals E over Z. We have to skip algebra steps. If we try really, really hard, we can write out the algebra, but for some of us, it's actually way easier to skip the algebra steps, which is why we skip them. But you kind of swap those out, the N in that thing, and it's going to be N equals P hat Q hat divided by that whole thing, E over Z squared, yeah. But we don't ever write it that way. In the end, it's going to be N equals P hat Q hat. Divide by a fraction, you take it up top and flip, and it is Z over E squared. So this is the equation right here. That's the equation, and it comes from the original right there. Yeah, we can always pause and look at this, but this is not an algebra class, so we do not have to derive it. That's a Z over E. So if we look buried in there, they have to give us the E. That's the thing that they have to give us. They give us the 90% confidence. Yeah. So they give us the 90% confidence, which is going to be alpha equals 1 minus 0.9. Alpha divided by 2 is divided by 2. I see 0.1. I see alpha over 2 equals 0.05. Yeah, that's what that's going to be. So we always do that z first. Yeah, so the z is going to be inverse norm 0.05, which is what? Okay, so that right there is the z. So they kind of do a couple of things here. First of all, if we read that, they have to imply the e. The e is going to equal 0.02. That's what the e is going to be. So if they give us a p hat, we find that. How do we find q hat? It comes from p hat. But they always kind of do that thing where we previously don't know something about the study. It's perfectly okay. If we don't know that right there, they're automatically 0.05. So we don't get something as accurate, but if we don't know from a previous study the p hat q hat, then we have to just mark both of them 0.5. Yeah, 50% is what we do with that there. So then what we get is 1.645 over 0.02. They have to tell us the E. They said 2%. So we just know that there's a lot of common mistakes with this. So that's basically the calculation. If anybody ever says 0.25, it is 0.25. That's what 0.5 times 0.5 is. So with N, we always round up. Always, always, always. I get 1691 is what I get. Okay, so they do the same thing here. We have to be careful here. What is it going to be? I always forget, that's why I derive it. But this is the equation for n. It's the other equation rearranged, z over e, yeah, squared. We just did all this here. So now they say assume a previous study has 0.19. What that automatically is the p hat is 0.19. The q is 1 minus 0.19. Yeah, the z, so we have the 1.645. Everything else is the same. 0.02. Yeah, so we always round up as we know for that. So if we calculate that, we always round up, I get 1041. That's what I get. So it's as simple as that. They give us the P, we plug in. If not, then the PQ is automatically 0.25. Okay, so here they're just seeing if we can do the readout there, so the confidence interval is actually given. So the point estimate, remember, for mu is just going to be sample mean. The point estimate for any population is just the related sample value. Okay, so margin of error E, this is a different margin of error formula. There's more than a couple, but there's two main ones. So margin of error for mean is Z sigma over square root of n. This actually leads into a whole nother conversation. Maybe we have it later, but there's two for mean. If we know sigma, it's going to be that. If we don't know sigma, it's going to use a t distribution. That Z and t, those are distributions S over root n. Those are more or less the same equation, but one is population information, the other one is sample. This one over here uses sample. So it just depends on what we have. And then the one that we literally just had, was proportion. This is the margin of error. It's solve for n. That's not what it is. Yeah, so that's the margin of error for proportion. So you basically have the three, but the two up top are going to be for mean. So now we're doing mean. Yeah, margin of error for mean. Okay, good. So they give us, we see the S sample standard deviation, therefore we're using this. So the t is a whole nother thing. It's inverse t. Let's do this t here. Once again, 95%. So alpha over 2 equals 0.025. I'm skipping a few steps. 1 minus the confidence divided by 2. For the t distribution, we have to have the degrees of freedom df. Degrees of freedom, which is just n minus 1 usually. Always. Later, when they get more advanced hypothesis tests and stuff, degrees of freedom can be all sorts of different stuff. But in the beginning, it's just n minus 1. So we have to do second bars on our calculator, that whole thing. And then we have what we call inverse t. It's just a different distribution. What do we have there? We have an area and we have comma df. That's the syntax. So we have to do the 0.025 comma, yeah, watch out for n. N is 36, so degrees of freedom is 35. And remember, there's like two problems in one. This is all just for t. So step one, which is a lot of mini steps, is just find the t. Then step two is plug into the entire thing, yeah? So all we're doing is finding that t right there. And we can call it t, or we can call it more appropriately t alpha over 2, but we don't have to be that fancy. So what do I get when I do that? 5. And it'll always come out negative because we get the left tail, but we actually want the right tail. T distribution is also symmetric. I get approximately 2.03. That's what I get there. Let's erase all this up top. So if they say find the margin of error, what is the margin of error? Of course, I'm not, every now and again, they just See if we can read it. I'm doing all this. Sometimes they give us the margin of error there, but they did not. So it's T S divided by the square root of n. So it equals 2.03 S, that whole thing. I am going to type in the whole thing, but I'm not going to write it. Divided by the square root of n. Square root of 36 is just 6. So I get the margin of error, 2 decimal places. This is what I get here. What do I get? I get 3.01. Yeah, so these processes are a monstrosity. We see what a pain confidence intervals are. So we just said this. I'm looking at 95. I'm looking at alpha over 2 equals 0.025. Yeah, I'm looking at inverse t, 0.025. What is degrees of freedom? I get 35. This is the same thing here. It's like, what the heck?